Environmental laws require many industries to monitor groundwater for contamination. An engineering firm is usually hired to collect the groundwater samples for testing. Some firms collect samples using a bladder pump. It's a small device that pumps water using pressured air. It's called a bladder pump because the flexible tube inside works like a human bladder connected to a catheter. When compressed, it forces the groundwater out of the pump and into the sample collection container. The pump is made from polyethylene because it's flexible and inert. The plastic is immune to chemical or biological reactions that could contaminate the water sample. The extruder melts the polyethylene pellets and forces the liquid through a tube-shaped die. Then it uses cold water to cool and solidify the poly. This produces a 1-inch tube. A razor cutter slices the tube into either 15 or 32-inch long pieces, depending on the pump size. They use a different die to produce a wider PVC plastic tube for the pump's housing. This tube goes on a computer-guided lathe, which cuts threads on the ends. The same lathe works with the computer-guided mill to shape the pump's top cap. It's also made from PVC plastic. They make the pump's bottom cap and bladder cap the same way. The lathe also carves a solid rod of stainless steel into a small disc-shaped weight. The weight helps the pump sink in the water and collect the samples. A technician preps the weights for engraving. He sprays them to hide their shiny surface. Without this masking, the laser would bounce off the surface instead of penetrating it. He loads the weights into the computer-guided engraving machine, then starts it up. The laser engraves the name of the manufacturer, the pump's model number, serial number, and other product information. When the engraving is complete, he separates the weights and washes off the coating with water. Next, they make the air supply line. They mix 2% concentrated blue polyethylene pellets with 98% colorless ones. They use the same extruder as before to create a narrow tube, as well as an opaque polyethylene tube for the pump's discharge line. Then they combine the air supply and water discharge tubes with a heat bonding machine. It binds them in 6-inch intervals. This lets engineers in the field cut the tubes to the length they need. Now it's time to assemble the bladder pump. They fit the top of the bladder into a cap that has a hollow center rod. They place an O-ring seal around another cap and attach that cap to the bottom of the bladder. The O-ring will prevent water from leaking out of the pump and air from seeping in. They insert a ball-shaped valve in the top cap. Then they attach a hose barb for connecting the discharge line. They insert the bladder into the pump's housing. They connect an air supply hose barb next to the discharge hose barb. They place the weight on the bottom cap of the pump and insert another ball-shaped valve. They complete the pump by attaching the bottom cap to the bottom of the bladder. When engineers submerge the pump in a well, water enters through the bottom and slowly fills the bladder. They drive compressed air into the pump housing via the air supply tube. The pressurized air surrounds the bladder, squeezing it. This forces the lower ball to close off the bottom of the pump, trapping the water sample inside the bladder. The trapped water moves the ball at the top of the pump, which clears the exit route. Then they send bursts of air to the pump in timed intervals. Each burst squeezes the bladder. This gradually forces the water sample to the top of the pump. It's then collected in a container on the surface.